1.3 similar triangles. So two triangles are similar if, okay, one of two things has to happen. If we have all three angles are the same, okay, so all three angles are the same, okay, in say, for example, triangle 1 versus triangle 2, okay, or, oh, and by the way, we call this AA, like angle-angle theorem, because if we have two angles that are congruent, right, say, for example, U and B and then T and A, then by default, because all three add up to 180, then by default that third angle is also going to be congruent, or their corresponding sides have the same ratio. Okay, so if we go like 2, 4, and then we'd also have to have 6 and 12 or 5 and 10, right? Like if it's like double, for example. Okay, and we'll get into that. So when naming similar triangles, the letters representing the equal angles are written in the same order. So, for example, angle A is here. That's going to be equivalent to angle T. Okay, and then we have angle B is here, and that's going to be equivalent to angle U. And then we have angle C, and that's going to be equivalent to angle V. And how we would write that is if we wrote ABC, okay, we would say triangle ABC is similar to triangle, and then we'd have to write the angle that corresponds to A, which is T, the angle that corresponds to B, which is U, and the angle that corresponds to C, which is V. Okay, so triangle ABC is similar to triangle TUV. Okay, so this first one, this is how we show that all three that the two triangles are similar based on angles. And then if we're looking at side ratios, okay, we have to label them the same way. So we have AB. So AB goes from A to B. That means in the smaller triangle, we'd have to go from T to U, TU. Okay, and the ratio, which means like when we divide it, is equal to, if we go BC, which is BC, we then have to go UV. Okay, and then if we go CA, so CA, we have to go VT, and we have to put them in the same order. Okay, so let's put these into questions. Okay, example 1. Given triangle ABC, so I always just draw it. Okay, let's see what it turns out to be. Angle A is 60. Angle C is 50. Okay, and then we're given triangle DEF. So let's draw another one. Angle D is 60. Angle E is 70. Are these triangles similar? Explain how you know. So we're going to use the angle, and then squiggle, okay? So if we wanted to solve for angle B here, we would go 180 minus 60 minus 50, okay? And we're going to end up with 70. So that would be 70. Now, if we wanted to solve for angle F here, angle F, we're going to do the 180 minus 70 minus 60. Okay, and we are going to get 50. So the 50 goes here. So what we're going to do is we're going to label these. So let's label like the first triangle first. Like A, B, and C are the angles, right? So angle A, angle B, angle C. And because we're using angle, and that's how we're stating whether or not these two triangles are similar, let's put what they're equivalent to. So angle A equals angle D. Angle B equals angle E. As soon as you get this, you can stop and it's similar, but let's just keep going. Angle C equals angle F. You can label all three if you want. Okay, but again, by default, if two are congruent, the third one by default is congruent. Okay, example 2. Let's change color. Given. So given just means I'm telling you. So this is a fact. Triangle ABC in this order, A, B, and then C, is similar to DEF. Find all missing measures of, well, EFD, or we can call this, if we want, triangle DEF. Okay? So we know that these two are similar. So AB, let's do angles first. Angles I feel are easier. So angle A is equivalent to angle D, right? The first letter here and the first letter here. So angle D is going to be 28. And then angle B is 121, so angle E is 121. You can check if these three add up to 160, and they should. Okay, actually, we're going to find the measure of, ED. That's the question. So ED is going to be right here. Okay, so let's set up ratios for the side lengths. We have these two side lengths, which give us a full ratio. So we have, for example, DF over AC, and we're trying to find DE over AB. So we get, if we sub these in, we get 16.1 over 20.1. And then we're solving for DE. ED, DE doesn't matter. We're just kind of going from D to E, and that's fine as long as we go from A to B, just to keep it consistent. Okay, so DE over 12.1. So if we cross multiply this 12.1 up, we'd get 16.1 times 12.1 over 20.1 equals DE. So if we put this into our calculators, 16.1 times 12.1 divided by 20.1, lots of 0.1s there, we get let's round, 9.7. And there's no units, so we'll just write units. Okay, example 3. In the diagram, DE is parallel to AC. So we have DE and AC. We have the parallel markings there, so that's good. Find the length of AC. So AC. So we know from like grade 9, if you guys remember, if we have parallel lines and we have a transversal, which just means a line that goes through the parallel lines, then we can actually call BA, like even if we extend it, if you look like this, there's our transversal, or these are parallel lines, this cuts through, there's our other transversal, okay? Our transversal, for example, stops here just like right at the corner. And that's totally fine. It doesn't need to keep going through. So we will treat this as though angle D and angle A are going to be equivalent. So let's first make a statement. Triangle BDE, we're going to go in this order, BDE is similar to BAC. BAC. Okay, so angle D equals angle A. Okay, because of the F pattern. Remember the F pattern? It looks like this or like this. Okay, that's what this is, upside down. And then angle E equals angle C. And then B, well, B is shared, right? It's in both triangles. So angle B equals angle B. So because of AA, like angle-angle theorem, and we only actually need to state 2 of these, but these are definitely similar triangles. So we're going to find the length of AC. AC is this one, so let's call this AC here. So we have these two side lengths, okay? And just be careful because we actually have to have like an addition here. So it looks as though BD, so let's go large triangle over small triangle in our equivalence, okay? So BD is going to be our small one, and we're going to write BA over top, but they give us BD, which is 48, and then give us DA, which is 12. We actually have to add those, okay, to get BA. So 48 plus 12, which is 60. Okay, and then so BD over BA, and then we have AC over DE. Okay, because those are corresponding. So BA, we have 60 over 48 equals AC over the 36. Okay, we're just subbing in these values, and then let's cross multiply. So we have 60 times 36, which is 2160. Okay, divided by 48, we get AC equals 45, and this is measured in centimeters. All right, example 4. In triangle MNP, so I just draw these out, MNP, side M is 7, so opposite M here is 7, N is 6, and P is 4. Okay, in triangle HJK, so I'm going to go in the same order. I went M, N, P, H, J, K. H is 17.5 centimeters, J is 15 centimeters, and K is 10 centimeters. We have to show that these two triangles are similar. So we're going to show this by side, side, side. And sorry, I didn't put that on the first page. I put angle, angle, but side, side, side is the other way. So we're going to go, I'm kind of a cheater. I always put the big triangle over the little triangle because then when we divide, it's like bigger numbers. So let's go in order. HJ is going to be over MN. JK is going to be over NP. And KH is going to go over PM. Okay, now we sub in 10 over 4, 17.5 over 7, 15 over 6. Okay, and if we were to divide all of these, 2.5, and just double check 2.5 and 2.5. So the ratios of the corresponding side lengths are equal, therefore they are similar.